How about we investigate forces in two dimensions? Here's our objectives. Hey, I have some good news. Carl just opened his own accounting business. Now he'll need to hang up a sign in the office. That's nice. Carl would like a big glass sign, but he wants to make sure the weight of it won't break the rope supporting it. 2 ropes are used, one on each side, to hang up the sign. Each rope can only support 160 newtons of tension, and the sign weighs 52 pounds. Whoa there, wait just a minute. We don't use pounds in physics, but 1 pound is almost equal to 4.5 newtons. So a 52-pound sign actually weighs 232 newtons. Now if the sign was hung with the ropes like this, the tension in each rope would be 116 newtons, much less than the maximum of 160 newtons. But Carl's gotta be fancy, so he wants the ropes to hang at an angle of 45 degrees. So how much tension will be in these ropes when they're each holding up 116 newtons at an angle? If we take a closer look at this 45-degree angle and use a little trigonometry, we'd see that we can solve for the tension force, which is the hypotenuse, by using sine theta equals opposite over hypotenuse. That means that for the rope to support the 116 newton weight, the tension in it will be equal to 164 newtons. And that's more than 160 newtons. The rope will break. On the weekends, Carl hires his nephew Marcus to drag big bags of money to his secret hideout. I'm sure Marcus gets paid very well, but we're not interested in Marcus's finances. We want to know how much friction is being overcome to drag this sled of money. Now, if you need to move something that's very heavy, what's the best angle to do it? Well, if it's really heavy, we get down low and push or pull it completely horizontally, no angle. But Marcus is definitely pulling at an angle. Using a spring scale, we find that he's pulling with a force of 204 newtons at 40 degrees above the horizon. Marcus is pulling upward and forward at the same time using the rope. The force pulling forward is found using cosine, that's the adjacent of 156 newtons. The force pulling upward, we use sine to find the opposite, which is a force of 131 newtons. So which force is equal and opposite to the friction? The adjacent force of 156 newtons or opposite force of 131 newtons? Yes, the friction is equal to 156 newtons while Marcus is pulling. Good job. Let's take a closer look at this diagram. You'll notice the dotted lines here. They're not true forces. They're the component forces of the pulling force. Because this image makes calculations difficult. Okay, time for a tricky but classic physics problem. The box is sliding down the ramp. How many forces are acting on this box? Well, if you said there's 3 forces, you're correct. They are force of gravity pulling down, a normal force supporting it, and friction as it slides. But the weight is at an angle, so we should find its components. This is where it gets tricky, because we are typically given the angle of the ramp, not the angle of the weight of the box. If we use a bit of geometry, complementary, supplementary angles, well, you'll just have to remember that when it's flat, we use cosine for the horizontal, but at an angle, we use sine for the direction it is slides. A 237 Newton box is sliding at a constant speed down a ramp with an angle of 31 degrees. What is the coefficient of friction between the surfaces of the box and the ramp? So, the force of gravity cosine will give us the perpendicular component and the normal force, which is 203 newtons. The force of gravity sine gives us the component parallel to the surface and the frictional force, 122 newtons. With this information, we can see that the coefficient of friction between these surfaces is 0.6.